Hello everybody, this is Dr. Noor Shah from University of Engineering and Technology, Peshawar. Today's lecture is about secant method, which is used for solution of nonlinear equations. F of x is equal to 0. I'll be explaining in this lecture, in this video, how does secant method works. And secondly, I'll be talking about how do we use calculator to find root of an equation by using secant method. Okay, so how does it work? Let me talk about that first. The main aim of this method is to solve a nonlinear equation f of x is equal to 0. And in previous video, I talked about how do we use Newton-Raphson method to find solution of a nonlinear equation whose iterations are given by xi plus 1 is equal to xi minus f of xi divided by f dash xi, where f dash xi is representing derivative of the given function f of x is equal to 0. Okay, you know the limitations of Newton-Raphson method. Newton-Raphson method may not work if the initial point or at any stage of the iterations this value f dash x that becomes 0. If we have f dash x naught, if that is 0, obviously you will change x naught. Sometimes it might not be 0, but after one or two iterations we get maybe f dash x1 is equal to 0, or we get f dash x2 is equal to 0. So whenever we get this type of issue or problem, Newton-Raphson method fails. That's the one issue with it. Secondly, we may have function f of x which might be have a complex representation. It might have a very complex expression in it, so finding its derivative is sometimes laborious. So we don't want to find derivative of that function, and we want to use the values of functions directly. For that purpose, we don't use tangent lines, we try to use secant lines. Right, so you know the discrete form of derivative f dash xi, that is given by f of xi minus f of xi minus 1 divided by xi minus xi minus 1. That's the discrete form of the derivative. And so what do? We may replace f dash xi in Newton-Raphson by this expression, and that will give you an expression like that: xi plus 1, that is equal to xi minus f of xi divided by the value of f dash xi, which is given here. And then after simplifying this, we get this expression, because you can just take this to the numerator, we get this expression. And then after applying, we can use this formula for secant method as well, and we can simplify this formula by taking LCM, and we get, after simplification, this formula. Okay, that is xi minus 1 f of xi minus xi into f of xi minus 1 divided by f of xi minus f of xi minus 1. So this formula is used for secant method. These are the iterations which are developed for secant method. Now, how does it work? The main steps are, we need to solve this equation, which obviously will be a nonlinear equation. That might be algebraic equations, it might be a transcendental equation. Okay, so what do? We first select 2 points, xi minus 1 and xi, near the root. The root may or may not belong to, may not lie between xi minus 1 and xi, but we are assuming that they will be close to the actual root. Then the next iteration, the next value that will be found by using this formula, as we derived in the previous slide, xi plus 1, that is equal to xi minus 1, f of xi minus xi and f of xi minus 1 divided by f of xi minus f of xi minus 1, where I is starting from 1, 2, 3, and so on. You can start from 0 as well, but if you start from 0, then you would initially you should know x minus 1 and x naught if you are starting from I is equal to 0. But if you start from I is equal to 1, what would happen? Initially, you should know x naught and x1, right? So for I is equal, let's start from I is equal to 1. So we would first find x2. X2 will be found as x naught into f1. F1 basically means f of x1 minus x1 into f naught, where f naught means f of x naught symbolically. And then we have f1 minus f naught. Right, in the next step, what would we do? We will be leaving this x naught, and I'll find x3 for I is equal to 2. This is for I is equal to 1. Right, so x3 will be what? That will be x1 into f2 minus x2 into f1 divided by f2 minus f1. That would give you x3. And so on. Then we find x4 unless we have a required level of accuracy. Let me do an example for it, and then I'll use calculator for doing those iterations. Okay, so let's solve this nonlinear equation, which is algebraic equation and a polynomial equation of degree 3. X cubed minus 2x minus 5 is equal to 0. So f of x in this case is x cubed minus 2x minus 5, and we took two values first. X naught is equal to 2 and x1 is taken as 3. So we would find first f naught, which will be minus 1. If you put x equal to 2 here in the given equation here, that will give you what? F of 2, which will be 8 minus 4 minus 5, which give you minus 1. And we would find a function value at x equal to 3 as well. So f of 3, that will be 27 minus 6 minus 5, which would give you 16. We don't care about the sign of the value of function at the initial taken points, which is important or which are important in case of a regular falsy method. It is not important in case of secant method. We do find the values of function at the given points, because when we want to find x2, we would need f naught and f1. If I may call this one as f naught and this one as f1, just for sake of simplicity. Okay, so if you want to find x2, what would we do? X2 will be, as I said earlier, it will be x naught into f of x1 minus x1 into f of x naught divided by f of x1 minus f of x naught. And then putting the values, x naught will be replaced with 2, whereas f of x1 will be replaced with 16, because we are having f of x1 is 16 here. You see that. So putting this value here in the formula, this is f1, this is our x naught, so this will be replaced with 2, whereas this will be replaced with 16. Similarly, the x1 will be replaced with 3, whereas f of x naught will be replaced with minus 1. After simplification, we get this is the first approximation of the root. Then we would find the value of function at this point, which will be something like that. You see that it is minus 0.3907 99917. And then we go for the next step, right? X3, which will be x1 f of x2 minus x2 f of x1 divided by f of x2 minus f of x1, which is obviously simplified is to get the next value, that is 2.08126366. And then we will be going for x4, where x4 will, the formula will become what? This will become x2. You see the formula for x4, I will just write it down for you. X4 will become x2 f3 minus x3 f2 divided by f3 minus f2. Now putting these values is x2, which is given as this one. You see, this is our x2, whereas x3 is this value, so we just put the value there. This is f of x2, which is f2. This is our f of x3, this one, sorry, and then we put the values to get the next value will be 2.0948 and so on, which is correct up to maybe correct up to 1 dp at the moment. So the next value is 2.0945. X6 and X7, they are repeated up to, you see, X6 is 2.094551,481, whereas X7 is almost same. That is 2.094551,482. Now, I'm explaining how do we get these values by using calculator directly. So let me open calculator for you first. Okay, so this is my calculator. So how would I do that? Let's do that. So the first step is the mode of calculator should be in radian. You must know that, and it must be in math mode. If you are not in math mode, so what would you do? You would simply press this mode button, and then you would simply press 1 to convert that into math mode. Right. So then we will be doing what? We would first find the value of functions f1 and f2, keeping in mind that initially I'll be calling x0 as my a, whereas x1 my b, and I'll just call e for f of x0 and f for my f of x1, and similarly then it will be replacing the values. So initially what would I do? I will just use this notation for it. So first I'd find e. So for finding e, I'll just press alpha first and then my e here, so e and then alpha, and then press this equal, not this equal, keeping in mind, because this is the output, giving you the output result where this is the assigning equality. So e is equal to just using this function and replacing x everywhere by a. So I'll just press alpha and a, and then we have cube of this one. So I may go to shift and then x cube minus 2a. So that's alpha, and then I go a, and then minus 5. And then separator, this is alpha and this one, because I'll be finding f as well. So again alpha, and then I press this one, this is f, and then equal, and then I'll write the same formula, just the difference will be replacing a with b. So alpha, and then we have b, and then we have cube of it, so shift and then this one cube. So b cube minus 2b alpha, and then we have b, and then we have minus 5. Again separator, because the next thing I would be using this formula, and I may call this one as my x. You can call it anything, you can call it c as well, but usually we call that x, doesn't matter. So x is equal to, this is the formula, so I'll just introduce the fraction. This is my a, this is my f, so I'll just press a into f minus b into e, that is x naught f1 minus x1 f naught divided by f minus e, that is f1 minus f naught. This is f minus e. You'll keep the same sequence. If you have f here, so a will be multiplied with f, b will multiply with e, and then we have f minus e, that will remain the same thing. Right, so we are done with it now. So I'll just press a calc first to get the value of to input the value of a and b first. So press calc, it will ask about a, so my a in this case is 2, so I just give it 2, and then press equal, it will ask for b. My b in this case is 3, so you'll just input 3, and if you press equal, that will give you the first value, which is f naught minus 1, you see that. Then the next value is 16, which was done here. If you want to check that, you can check it as well. So that is 16, you see that. So f of x1, which is basically f3, that is 16. And then if I press equal, this equal now, it will give me exactly this value. You see 2.05882359. This is my x2 now. Now, what is the process, right? Because next time I'll be replacing x naught with x and x1 with something with x2. X naught will be replaced with x2 and x1 will be replaced or will remain same x1. So what is the process in this case? In this case, I'll be changing alternately the values of a, b with x, just to get to these x7 and so on. So if I press equal again, it will ask me about the value of a. So in the first step, I would replace a with x. That would mean that we are basically changing the value of x naught with x2 now. So if I give the value of x to a, I press equal, it will ask about b, but I don't change b this time. I'll just press equal. It give me this value, which is will be the exactly same what we have here, this value minus 0.39. This is, you see that is f2, my f2 now. I press equal, I'll get same 16. This is now my f1, this is f2, and then I press equal, it will give me the next value of x, this improved value, which is 2.08 and so on. The value you may see here, 2.081263 and so on. So this is my second one. Now this is the x3 value. See, now if I press equal, it will ask about a again, but now in this case I will not change the value of a. I'll just press equal and change the value of b this time with x. So I'll do this alternatively. So I change now b. Next time, what would I do? Now see, my f2 is same. This is my f2 now, and f3 will be now f. This is my f3. You see, minus 0.1472057. Okay, and then I'll find x again, which is 2.0948. This is mine of x4. Now what would I do? This time I would replace a with x. As I said earlier, we will be replacing the values of a, b with x alternatively. So this time I'll replace a with x, press equal, don't change the value of b, press equal, that give you e, which is obviously f of a, and this is our b, f of b, which is remain the same. Then I would find x again, which is 2.0945, which is my x5 now. You see that 09459431. Keeping in mind, next time I'll be replacing now b with x. I don't replace a with x this time because previously I replaced a with x. This time I'll replace b with x. So just alpha and then x, press equal, then next equal, and you see that the next value, which is our x6, which will be 2.09551481, exactly the same thing, and then press equal. It will ask about a, right? So we have to replace now the value of accordingly. Previously we replaced b with x. This time we would replace a with x. So you see this one, then press equal, and then we press equal again. You see the value of e is getting very small. That means we are almost reaching towards the root. So if you press equal again, then the next value will be 2.09451482. This is this value, you see, it's a x7. So this time we replaced a with x, and next time we'll be replacing b with x, and so on, so on. You can go towards this improved result. And in the next step, there will be no change. The value of a and b, they will become similar, and the value of e and f, that would become almost 0. And that will obviously converge to the actual root. So that's the procedure. You see, there is a difference between a secant method and regular falsi method. The formula is used in both cases would remain the same. The difference is in the procedure. In secant method, we don't look, or we don't put in account or take into account the sign of the value of the function. We don't decide on the sign of the function's value. We just alternatively change the value of a b with x. Whereas in case of regular falsi method, what do? Every time we check sign of the value of function, and we leave the 2 points where the function has opposite sign and drop the next one. So there is a difference. The formula is the same. Both are using secant lines, whereas the procedure by which we take the next 2 points for the next iteration, that is a different, right? So I hope it's clear to everybody. If you learn something from this video, so subscribe to my channel, and thank you very much. See you in next video.